Alright, let's carry on with that review of section 9.2. Number 14, a history teacher gives a 10-question true-false exam. How many different ways can the test be answered? There are 10 questions, and each one of them has 2 possibilities. So those 2 possibilities get raised to the 10th power. So there are 1,024 ways to answer this question, guessing or otherwise, but there's only 1 out of 1,024 ways that you actually get them all correct. So the odds are not in your favor if you guess. You might want to study. On to number 15, right here. A typical Social Security identification number looks like this. How many Social Security numbers are possible if the first digit of each group can't be 0? Well, we know that we have 10 digits, but if we can't use one of them, that means the first digit in each group has to be a 9. But there are no other stipulations on the other numbers, so they can be 10s. So you have 900 times 90 times 9,000. Or you could just, put the 10s in there. It's no biggie. And just multiply everything together using your handy dandy calculator. And you're going to end up with something really fantastic. But let's make sure we can see it. 900 times 90 times 9,000. And you end up with 729 million. Maybe Jesus will put that in my mailbox. Alright, on to number 16. Number 16 is one of the harder ones, and so is number 17, which I didn't get to copy here. But the probability of a family with 6 children having 3 boys and 3 girls, one of the first things that we could do is we could create a tree diagram of this phenomenon, starting with having a boy or a girl. But you're going to need to leave a whole lot more space than this, because you got to go boy, girl, and then you got to go boy, girl, and you got to do this for 6 possibilities. Boy, girl. And then you do it again. And you keep going until you have, this is my first child, this is my second child, this is my third, fourth, fifth, sixth. And then you read along the branches, and you're going to find that there were 20 out of 64 possibilities, which reduces down to about 5 out of 16. Alright, now for the heights and frequency distributions, what we actually worked on today in class. Alright, so if we're going to work on a frequency distribution, let me move this off. All a frequency distribution is it takes different values, and usually one at a time, and sometimes it's a range of values, and you figure out the frequency of those particular scores. So these numbers here represent the heights of 20 students. So what we do is we've got the different values, and we usually put them in numerical order. So 65, 66, 67, 68, 69, and 70, because that seems to be as high as it's going in this list. So these are my heights. How tall the folks are in inches. And then I just find out how many 65s I have, and you just make tally marks, and then you count those tally marks, and that represents the frequency. And then you can take this information and find the mean. You can find anything about this. So this column is all about the frequency, or the tally marks. How many 65s? How many 66s? And this is called a frequency distribution. You can sometimes look at a distribution and kind of tell, like, okay, most of the people in this room are, lower than 70. Most of them are higher. Some of them are right there in the middle. So let's see what we've got here. All right, now as you do it, we start with 65. We put a tally mark right here, mark off the 65. Do the 68, and you can kind of keep it orderly that way. And that way you won't lose your place in terms of where you are next. 2 67s, a 68, 66, 69, 70, so on and so forth. Alright, and then you can mark off what your tally is. You had 4 65s, 2 66s, 5 67s, 3 68s, 4 69s, and then 2. And it's a pretty nice spread here because they're very close to each other, and you can take the average and see how far away they are from that. That's the standard deviation. So a lot of statistics can be done with a frequency distribution, and that's all you have to do there. All right, with the next one, we're talking about wages, and it still kind of works the same exact way. You just write down the wages, and then you figure out, the frequency distribution. So you can look at 60,000, and you just kind of look at it like I got 60,000, and there's 1, and there's 2. So you can say there's 2 60,000s, and that looks like a pretty big number. And then we have any 50,000s. There's 1. We don't have any 55,000s. That's right in between there. So you kind of get the gist. You go ahead and make yourself a column, starting to count by 5s, and I guess you could start the count at 15,000 and work your way all the way up to 60,000, and then do the frequency distribution. The same thing goes for the next one with the wages of the employees. Figure out how many you have in the range of 1 to 20. So 1 to 20 would be 20, 15,000, 15,000, 14,000, 16,000, 18,000, and 18,000. So 1, 2, 3, 4, 5, 6, 7. There's 7 of those. And then you could figure out how many you have in the range of 20 to 30,000. So that would be 1, 2, 3. And then how many you have in the range from 31 to 40,000? 1. How many from 40 to 50? 1. And how many for over 60? 1. So that's the frequency distribution of this set of wages. So the majority of the folks are in the lower bracket of earning money at this particular company. Now, when you've got something like a pie chart, this is more of a simple little common sense problem. This represents the amount of electricity used in a month. And it says that in this home, in this particular month, they used 1,100 kilowatt hours of electricity. And we want to know how much of this was represented by the water heater. So we just multiply it times 0.12. See, those percentages never ever go away. So we put it in the calculator, and we have 1,100 kilowatt hours times 12% of 0.12. And that gives us 132. 132 kilowatt hours of electricity was used by the water heater. And now the very last one that we worked on before we said happy weekend is this one, where we're given the gross profits for a company, and we've got to figure out what each one of these represents as a percentage. So the first thing we need to do is take out our calculator and add up all of these numbers. When you add all those numbers up, you get 360,000. So that was the total profit for the month of January. Now, how much of that is represented by the appliance department? So what you do is you put your 20,000 over your 360,000. Now, let's talk about all these zeros. With all these zeros, we can kind of cross some of those bad boys out. We can cross out this one, and this one, and even that one. So we're left with 2 over 36, and we can just put that in the calculator. 2 divided by 36 times 100, because we need it to be a percentage. Keep change. We end up with 5.56. We're going to go ahead and round to the nearest 10. So that's approximately 5.6%. If we were going to do it exact, it would be 5 and 5/9, because the 5 keeps on repeating. Any repeating decimal can be placed over a 9. Alright, then let's do the automotive department. And when we do the automotive department, we're also doing the nursery. So that's 10 over 360. Because those 3 zeros in the back, we just sort of cancel those out. And that would be 1 over 36. So 1 divided by 36 times 100 gives us a percentage of approximately 2.8. Alright, then as we look at that, we know that that's the nursery, and we know it's the automotive. So we've got 5.6%, 2.8%, and 2.8% down here at the bottom. Now let's look at the other two that are left, the clothing department and the grocery department. Alright, with the clothing department, we can just do 55 divided by 360 multiplied times 100. So 55 divided by 360 times 100. You could reduce it by 5, but we'll go ahead and keep it moving, and we get 15.3. Then, of course, the final one. And this is just approximate because I'm rounding to the nearest tenth. So for the very final one, we've got 265, and we're just going to divide it by 360. It's another problem that we can reduce, because 5 will go into both of these numbers, but we can use our calculator as well. So that's going to give us 265 divided by 360, and we get 73.6. Now sometimes in the course of rounding, we'll end up with something like 99.9 versus, the actual full 100%, so just be careful when you round. But that's the answer for the grocery department. Again, that's all you have to do.